When we think about what shapes Earth's climate, we typically look down at our planet: greenhouse gases, ocean currents, and volcanic eruptions. But what if we should be looking up instead? What if our journey through the vast Milky Way galaxy has been quietly influencing Earth's climate for millions of years? Recent scientific research has revealed something remarkable. Approximately 14 million years ago, our entire solar system traveled through one of the most densely populated regions of our galaxy, potentially altering Earth's climate in ways we're only beginning to understand. Our story begins with the Radcliffe Wave, a massive, undulating structure of gas and dust stretching across hundreds of light years in our galactic neighborhood. Using data from the European Space Agency's Gaia mission, an international team of researchers has determined that our solar system passed directly through a portion of this wave, specifically the star-forming region we now call the Orion Complex. Imagine it like a ship sailing through varying conditions at sea. Our sun encountered a region of higher gas density as it passed through the Radcliffe Wave in the Orion constellation. This cosmic crossing happened approximately 14 million years ago, according to the team's calculations. Professor João Alves, an astrophysicist at the University of Vienna and co-author of the study, notes that we passed through this region as well-known star clusters like NGC 1977, NGC 1980, and NGC 1981 were forming. If you're wondering where this happened in our night sky, it's actually quite easy to locate. Look for the Orion constellation, one of the most recognizable patterns of stars visible from Earth, and find the Orion Nebula, also known as Messier 42. Our solar system came from that direction, but what does this galactic journey have to do with Earth's climate? As our solar system traveled through this dense region of the galaxy, it would have encountered significantly more interstellar dust than usual. This cosmic material could have compressed our heliosphere, the protective bubble created by our sun that shields our planets from interstellar particles. With a compressed heliosphere, more of this cosmic dust could have reached Earth, potentially depositing layers of extraterrestrial material that might still be detectable in geological records. While current technology may not be sensitive enough to find these traces, future detection methods could reveal this cosmic signature buried within Earth's layers. Intriguingly, the timing of this passage through the Orion Complex roughly corresponds with a major climate event on Earth, the Middle Miocene Climate Transition. This period marked Earth's shift from a warm, fluctuating climate to a cooler, more stable one, featuring extensive ice formation in Antarctica. While scientists believe this climate transition was primarily driven by changes in carbon dioxide levels, the research team suggests that the increased cosmic dust from our Orion passage might have played a supporting role in this climate shift. As Makoni explains, Ephraim Makoni, VO. While the underlying processes responsible for the Middle Miocene climate transition are not entirely identified, the available reconstructions suggest that a long-term decrease in atmospheric greenhouse gas carbon dioxide concentration is the most likely explanation, although large uncertainties exist. However, our study highlights that interstellar dust related to the crossing of the Radcliffe Wave might have impacted Earth's climate and potentially played a role during this climate transition. It's important to note that any climate effects from this interstellar dust would have occurred gradually over hundreds of thousands of years, nothing like the rapid warming we're experiencing today due to human activities. The researchers emphasize that the current climate change is happening at an unprecedented rate over mere decades, primarily due to human influences. This research opens fascinating new possibilities for collaboration between astronomers, geologists, and paleoclimatologists. By working together, scientists from these different fields might be able to identify geological anomalies or isotopic variations that align with this ancient cosmic crossing. This study is important because it adds a small puzzle piece to the recent history of the solar system, helping to place it in the context of the Milky Way. We are inhabitants of the Milky Way, The European Space Agency's Gaia mission has given us the means to trace our recent route in the Milky Way's interstellar sea, allowing astronomers to compare notes with geologists and paleoclimatologists. It's very exciting. The research team now plans to investigate other cosmic environments that our Sun has encountered throughout its voyage through the galaxy. By integrating measurements of cosmic dust, radiometric dating, and climate modeling, they hope to build a clearer picture of how our galactic movements might have influenced Earth's history. This research reminds us that while Earth's climate is primarily shaped by forces on our planet, we are also travelers through a vast and dynamic galaxy, one whose subtle influences may have been shaping our world all along. What other cosmic factors might be influencing our planet in ways we haven't yet discovered? The answer may lie written in the stars and in the rocks beneath our feet. For more on this story, find a link to the article on Earth.com in the description.